So today we're going to learn about, yes, and CPCTC, of course. So today we're going to do the last two, which is AAS and HL. So let's get right into it. Definition number one, we have AAS. Can I have a volunteer read for us AAS congruence theorem?
If two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of the other triangle, then the triangles are congruent.
Perfect. So I want everyone to go ahead and take about a minute to copy down the definition as well as the two triangles underneath, which are a good example of AAS. Go ahead and copy down and start thinking about why AAS can work for us. Perla, I'll allow you to answer it in just a minute. I want everyone to have a chance to write things down first. All right. So Perla, what were you gonna say? Why do you think that we can do AAS?
Okay, so if we know that the two angles are congruent, we know that all the angles inside the triangle are always equal to 180.
Right.
So we know that the angles are going to be congruent. And then let's say in this example, we find out the measure of angle B or angle E. We can get the SAS.
Exactly. You are on it, girl. Good job. So in other words, we know that all three angles have to add up to 180. Angle A plus angle B plus angle C have to equal 180. Well, on the other triangle, the same thing is true. On the other triangle, angle D plus angle E plus angle F have to add up to 180. And if A and C are congruent to D and F, then it has to be that angle B is congruent to angle E, and therefore we have SAS. Now, everything I just said, we're about to do on the next page, so don't worry if I said that a little quickly, but we're going to do a very step-by-step, oh, you're right, ASA. We're going to do a very step-by-step version of what I just said. So basically, the reason AAS works is because from AAS, you can get ASA. So we went from having AAS to now we have ASA. Okay. So let's go ahead. I'm going to do like a more step-by-step proof. This looks long, but I promise you it's exactly what we just said, but in a proof form. So we're just going to go step by step, and we're going to see why AAS works. So the first thing is...
I do number two.
Sure. But let's start out with our first statement because it's missing a piece. So statement number one says angle A is congruent to angle D. So I'm going to highlight those. And then it says angle C is congruent to angle. What is it missing there? Good, Perla, F. So C is congruent to F, and that's given. Tyrone, can you read the second statement and then tell me the reason?
Measurement of angle A plus measurement of angle B plus measurement of angle C equals 180.
Good, and what's the reason for that?
Is it the triangle sum theorem?
Yes, sir. Triangle sum theorem. Triangle sum theorem. Perfect. Okay, so now we know this piece of information. Then it says the measure of angle B equals 180 minus measure of angle A minus measure of angle what?
C.
Yeah, C. And they're basically just trying to get angle B all alone. So they're subtracting and they're just making those angle A and angle C go over to the other side. And that's our subtraction property of equality. Number 4, measure of angle blank plus measure of angle E plus measure of angle F equals 180. What's the missing piece there?
D.
D, good. Okay, that's the triangle sum theorem. And then finally, measure of angle E equals 180 minus measure of angle D minus measure of angle, good, F. So they just did the same thing to both triangles. So now I have measure of angle B all isolated, and I have the measure of angle E isolated. All right, who wanted to do 6? Tyrone?
The measurement of angle A is equal to the measurement of angle D, and the measurement of angle C is equal to the measurement of angle F.
Good, and what's that theorem?
Is it the definition of congruent angles?
Exactly, good. Definition of congruent angles. All right, and then I have the measure of angle E equals 180 minus the measure of angle A minus the measure of angle C. What do you guys think? Which
Substitution.
Subtraction. Wait.
Jalen had it, substitution, yeah.
Yeah, substitution.
Substitution, cool. So yeah, we substituted, instead of what they had over here, which was D and F, they replaced that with A and C. All right, and now I have measure of angle blank is congruent to measure of angle B. What do you guys
E.
think? E, good. So we finally can say that B and E are congruent. Okay, and then finally, measure of angle B is congruent to measure of angle E. So they're just kind of doing that definition of congruent angles again. And now that we know that the 3 angles are congruent to each other, which triangle congruence theorem can I use here? There's like a little blank. I'm supposed to fill in the blank here. Well, yeah, we can't do CPCTC because I don't know anything about those other 2 sides, but what do I know?
AAS.
Right, but I'm trying to prove that AAS works. So I can't use that as my reason because that's what I'm trying to prove. Good, ASA, that's the one. That's the one that I already know is true, so I can use it as a reason. Because I have angle, side, angle, and angle, side, angle on both triangles. So this is kind of like a longer way of saying what Perla already told us, which is that when you have AAS, you can actually get ASA out of it. So they're kind of similar. So AAS can lead to ASA. So do I have any questions on why AAS works? Why I can say that it's true?
No.
Awesome. So now let's see if we can use it, and we're going to do a couple of examples, and I'm going to see if I can use it to prove these 2 things. or in the two examples. You want me to go back really quick? Really quick. Here you go. Let me know when I can move, okay? Okay. Okay. So let's see if we can use AAS in this example. So I am given that AC is congruent to EC. So AC and EC. And I know that M and N are, what's that symbol? Not congruent.
Transversal.
Parallel. Yeah, parallel. You can always remember parallel because it just looks like a parallel, two parallel lines. So M and N are parallel. Okay, so that's all I know so far. But based on that information, what else can I figure out? So actually, you know what I'm going to do here is we're going to do a little proof on the side. I know they didn't give us one, but we're going to kind of make one. So I want everyone to just copy down a little chart. Since they're not giving us one, this doesn't have to be perfect, but we're going to use it to organize our thoughts. So far, I'm just going to write what I already know. Okay. But based on this information, what else can I figure out? So anyone see anything else that I can highlight or write down? And Tyrone, to answer your question, AC and EC are not, that's not reflexive property. Because remember, reflexive property is whenever you have something like, let's say a triangle like this with a line down the middle, that line down the middle would be the reflexive property. Okay. So I'm trying to prove, remember, don't lose sight of my end goal. I'm trying to prove that ABC is congruent to EDC. But right now, what's the only thing I know so far that's congruent between both of them? So let's start with that. What's the only thing that I have so far that is congruent between both triangles? Right. All I have right now is AC is congruent to EC. So in other words, I have a side. So here there's three possible sides and there's three possible angles, right? So far I just have one side. I'm going to need some more information to prove that they're equal. DC and BC. Okay, so Emily's asking whether I can say that DC and BC are congruent. Can I say that? Let's think about it. Is that a statement I can make with full confidence? Unfortunately, no. And why not? What would they have to tell me in order for me to know that with full confidence? Right. They would either have to tell me straight up, they would have to say BC is equal to DC, or what could they say about point C? Right. They would have to tell me that that's the midpoint. But they didn't say either of those things, so we can't make that assumption, unfortunately. I know it looks tempting, but I can't do it without any more information. So that's not going to help us out. Let's think, okay, so we can't really figure out if this side is equivalent. A, B, and D, E. Okay, let's check that one out. Is there any given information that tells me that AB is congruent to DE? Nope. They also don't tell me anything about those two, so I can't assume them. I can't assume it. You have to be given the information. So we also can't say anything about the second side. So far, all I know is one pair of sides. I can't do anything with the other two sides, so let's think about the angle measurements. Which angles might I be able to compare? D and A, or B and D. Okay, so let's take a look. So D versus A, is there any theorem or anything that can compare those two? No. But what about D and B, like Jalen suggested?
The alternate interior angle theorem.
Alternate interior angle theorem, exactly. Because if you think about this as being the transversal, if this is your transversal, then I know that these two angles are alternate interior angles. And what do we know about alternate interior angles? We know that alternate interior angles are
Congruent.
congruent. So angle D is congruent to angle B. And that was the alternate interior angle theorem. So good job, Jalen and Perla, for putting that one together. So now I have one side, I have one angle. I need to see if there's another angle that I can prove. A and E. A and E. Yeah, this is another
Alternate interior.
alternate interior angle, except this time they're looking at this line as the transversal. So when the blue line is the transversal, then you have another pair of alternate interior angles. So good. Okay, so now we have a little more info. Angle E is congruent to angle A. Cool. So I have a side and I have two angles. Now let's check if that's enough information. Is this AAS? Yes, it is. So now what can I say about the two triangles? They are congruent. So let's go ahead and write that down. So triangle ABC is congruent to triangle EDC by the AAS theorem. Okay, good point, Jalen. Jalen makes a point though. You might have made a typo, but could you possibly also do ASA? Which angle is missing in order to do ASA? ASA. Not that curse word that Jalen put in the chat. Jalen. Which angle do I need in order to do ASA? It's okay, Jalen. Which angle would I need in order to do ASA? Right, angle C. Okay, so let's take a look at angle C for a second. If I had angle C on this side of the triangle, could I get angle C on the opposite side? Yeah, what's that called?
Vertical.
Good,
Vertical angle theorem.
vertical angle. So you could have also done ASA if you use the vertical angle theorem. But that's not what the question was asking, so we didn't do that one. But you could have done it. So at the end, we do have two congruent triangles. Do I have any questions on this proof? This, guys, you just did a proof from blank, from a completely blank slate. So that's pretty awesome. Let's do another, let's do one more. I'm gonna do the same thing. We're basically gonna do a blank proof. And I think I kind of came up with this on the spot, but I think I like this. We're going to have the 3 sides and the 3 angles, and we're going to check them off as they go. So given ABC is congruent to DEF. Okay, so I know that this angle right here is congruent to this angle up here. So far I have one pair of angles. Then I also know that BC is parallel. BC is parallel to EF. So let me go ahead and write that down. They give me a lot of info. They also tell me that AC is congruent to DF. So AC is congruent to DF. So I actually also have a side. Okay. So I have an angle and I have a side. Now, in order to do AAS, I would need to figure out one more angle. So let's think about which angles I might be able to make congruent. Does anyone have any ideas? D and A. D and A. Okay, why do you say D and A, Tyrone? What allows you to say D and A are congruent? Okay, so you change your mind so that you don't think it's DNA? Yeah, okay. That's right. So Tyrone kind of realized in his head, we don't know anything about if BA and ED are parallel to each other. So since we don't know anything about that, we can't make any assumptions about angle D or angle A. But since we know that BC is parallel to EF, I'm going to extend them. Since we know those two are parallel, then we can know for sure that angle C is congruent to angle F. And what are those to each other? C and F. Look carefully. You might have to rotate your screen a little bit or rotate your head a little bit. What is the relationship between angle C and angle F? Good job, Tyrone. Those are corresponding angles. So what's the theorem that I could use? What's my theorem?
Corresponding angles theorem.
Good, the corresponding angles theorem. And I'm kind of running out of room, but that's what that says, corresponding angles theorem. So now I have everything I need. What's my final statement going to be? What's my final statement, guys?
ABC is congruent to DEF.
ABC is congruent to DEF. Good. And I know this because of not CPCTC. I only know 3 things. AAS, good. All right. Questions on AAS and how to use a theorem, any part of this proof. Which word, Jalen? Proof or brain? Okay. Now, moving on. Moving on. Let's look at an example and let's see how many different theorems I can use to prove that these two triangles are congruent. So start looking. Take a look at the triangle. Look at what we have. Think about which of these we could possibly use.
Miss, can you go back real quick?
Yes, I'll go back real quick.
Okay.
All right. So here we are. So taking a look, I already see some answers in the chat. How many different theorems can you possibly use to prove that these two triangles are congruent? So I see ASA and AAS. Anything else? That's it? Okay. So let's take a look. So if I'm doing ASA, let's label these points so that we can talk about them. If I'm checking to see if ASA works, which angles and which side am I looking at?
Angle A and C, they're 90 degrees.
Mm-hmm. So both of
And-
these are 90.
And B.
And B.
Well, B isn't 90, but it's an angle.
Right. So angle B and the other angle B. Okay, so those are my two angles. And then which are the two sides that I'm going to be looking at?
The one in between line segment AB and the one in between line segment BC.
Okay, so this one here. And then this one here.
Wait, it is line segment AB and BC.
Yeah.
My bad.
Good. So AB and AC. Okay, good. So I have A, I have S, and I have A. So I have ASA. Good. So ASA definitely works. What about SAS? Do I have SAS?
No, because you would.
Yes, you do.
Yes,
you do.
Pearl?
Oh, yeah, because you do have two. Okay.
You have the reflexive one in the middle,
Mm-hmm.
BD or DB. You
Mm-hmm.
have the angle on top over here, B.
Mm-hmm.
And then you have line segment AB or BA, whatever you want.
Mm-hmm. Good. So I have AB and BC. So there you go. I have S, A, S, SAS. So SAS also works. All right. What about SSS? What about SSS? Does SSS work? Guys at home, you guys are gonna have to do it for us because it looks like the power went out at school. So now I'm listening. I want to hear from Daniel, Jalen.
Yeah, the power did go out.
Yeah. Oh, and you're on your phone, Janelle, so you're good, right?
Okay.
Yeah.
Okay. So anybody else? Samaj, Alejandro, Eric, Jalen.
SSS.
Can you use SSS in this case?
Yes.
Okay, so what are the
Because the side in the middle and the sides on the side are the same.
Mm-hmm.
And if you do the math with those two sides, you figure out that AD and DC or CD and AD are the same.
Ooh. Very interesting point, Daniel. What math are you talking about that you could do?
You add the two sides.
There's a specific theorem I'm thinking about.
I don't know the specific names of the theorems.
Well, let's think about what we have here. What type of triangles do we have?
Are they regular triangles?
Not regular, because remember, regular means that all three
Yes.
sides are the same.
Irregular.
There's a specific type of triangle, and I know because they have one specific type of angle.
The
Right
right
triangles?
angles.
Yeah, the right angles tell me that these are right triangles. So I don't know if Perla, if you guys heard this part that Daniel was saying, but my question was, does SSS work, right? And Daniel is saying that yes, it does.
Yes.
Because, can you explain it one more time, Daniel? The way you said it was perfect.
Because you can use the two sides, the one on the left, the ones on the left and right, and the ones in the middle to get those two sides, and then use those to find the last one by adding.
So he's saying that you can do some math and figure out the measurement of angle AD and the measurement of angle DC. So my question was, is that true? Can you do that?
Yes.
And Daniel's saying yes. I'm not saying he's wrong, but I'm asking you like how you can do that.
I forgot the name of the theorem.
You forgot the name of the theorem, but can anyone else think about a theorem that might help
What
you?
was the question?
So,
Angle
okay.
side theorem?
Say that again?
The angle side theorem? I forgot.
So I guess the question is AD congruent to DC?
Yes.
Yes.
And if so, how do you know that?
I mean, they both have right angles and like.
Okay. But they didn't give us that information.
Can I give it a try, miss? Because like BD is like bisecting in the middle.
Does it
No?
tell you that?
Okay. No,
No.
I'm just like thinking. I'm trying to think something that makes sense.
If they
Is
told
it
you that,
because
then
they're
sure.
both 90-degree angles?
It has something to do with the 90-degree angle, yes. That's
Right
that's part of the
angles.
puzzle.
Is it a theorem or a postulate or something?
It has to do with a theorem.
The right angle theorem? Right
That's not a
triangle?
theorem.
Dang it.
But it has to do with right triangles. You can only use this theorem if you have right triangles.
I feel like I know it, but it's on the tip of my tongue.
I'm going to give you one last kind of clue. I'm going to call this side X, Y, W. Oh, what?
Is it the Pythagorean theorem?
Yes, sir. It's the Pythagorean theorem.
Yay!
Because the Pythagorean theorem tells me, and we'll talk about this a little more in a second. Daniel kind of skipped ahead like 4 slides, but that's okay. We're doing it anyway. Pythagorean theorem tells me that on the triangle on the left side,
I'm 5 universes ahead of you.
yeah, you are. Let me color code everything to make it nice and visual. Hold on. Okay, so on the triangle that's on the left side, I know that x squared plus y squared equals z squared. That's the Pythagorean theorem, right? Now, I know that angle W or side W is equal to side X, so I'm just going to replace that with an X. Can somebody give me the Pythagorean theorem for the triangle that's on the right side?
Wait, what?
So this is the Pythagorean theorem for the triangle on the left side. Can somebody give me the Pythagorean theorem for the triangle on the right side?
Would it be x plus? Is that a wait? I'm kind of confused.
The bottom one is a V.
X plus y. I mean v.
X squared plus V squared
equals something squared.
What's that letter? Yeah,
Uh,
Z.
Z squared.
Yeah.
I couldn't see the letters.
Okay, so those are my two Pythagorean theorems, but what can I make equal to each other now that I have this information?
AD and DC.
AD and DC, yeah, because everything else matches, so this part right here also has to match. So I have y squared has to be equal to v squared, which means y has to be equal to v, which is why we can make that statement. So that was, okay, this one was definitely a harder, trickier thing to realize. We're going to talk about it. Like I said, Daniel was like 3 years ahead of me. So I'm going to circle it, but I will explain it further in a couple of slides. So you can use C. And now back to my original question. Let me unhighlight everything so we know what we actually know. Can I use AAS for these two triangles?
AAS.
Mm-hmm.
I want to say yes.
Yeah, can we highlight which sides and which angles, or two angles and one side?
Uh,
For AAS to work.
Can we do BA and side AB?
So AB, and then angle D, you said?
Yeah, but I don't think that's gonna work. Never mind.
Yeah, because we don't know anything about that one.
um,
Think about two angles and a side that is not included. So two angles, which two angles is it going to have to be?
B, A, or C.
A and C. What other angle?
B.
B. And then which of these sides is the non-included side?
B.
Side. Give me two
Oh,
letters.
wait. B and D.
BD.
Because it's the
Yeah.
reflexive one.
Yeah, the reflexive one. So there's my AAS. Two angles and the non-included side. Which one is the included side?
A, B, and B, C.
Right. Those would be the included side. So this right here is included because, why is this one included? How come AB is included? What is the word?
Wait, can you give me the first letter?
No, you were saying, you say what you were going to say.
No, I was, oh my God.
So how come, okay, what makes the red side length an included side between A and B? If angle A and angle B are my angles, what makes side AB the included side?
It's getting
It's included because it's in the middle of the two angles.
Yeah, exactly. So because it's in between those two angles. So that's why we can't use that side, because we're talking about a non-included side. And that's why AAS would work. Okay, so you could actually use every single theorem on these two triangles, but now I'm going to explain a little bit. Well, we'll get to why SSS works and the Pythagorean theorem.
Wait, miss, would it be B, C, then BD? I'm kind of confused on how it works.
C and BD? What do you mean?
Like the order it will go from for AAS.
So this would be A, angle A and angle C, that's the first A.
Uh-huh.
Angle B, both of those angle B's are the second A.
And then BD.
And then BD would be the side because that's the non-included side.
Oh, okay, I got it. Thank you.
AAS. Whereas, on the other hand, if you had this side right here, that would not be AAS. What would that be?
ASA.
ASA, because that side is in the middle. So that's the difference between AAS and ASA. That's a good, I'm glad you guys asked that question because I wanted to make sure to clarify that. Okay, let's do one more proof. One last proof. Let's see if we can figure this one out completely on your own. Okay, good. First one's given. And anytime I have my given information, I am going to highlight it on my diagram. So I know B is congruent to D. And I know that AC bisects BCD. So where's BCD? That's this one right here. That's that angle. And what do I know about a bisector? What is that? What did I just do by bisecting?
It cuts it in two.
It cuts it into two, and specifically two what?
Triangles.
2 equal parts.
Oh, two
Equal parts. Yeah. So what can I highlight now? What do I know now? If AC is cutting that angle in half.
That they're both congruent.
Right. So this right here is congruent to that right there. And what's statement 3 going to be then?
AC. Wait. This is the definition of an angle bisector.
Yes. So what did I just highlight on my graph, on my diagram?
Angles B, C, and D. That's what
Yeah.
you highlighted. That's not the answer.
Nope. What relationship did I just indicate on my diagram?
AC.
Do I know anything about side AC? About
Oh no. ABC and ADC.
A, B, C, and A, D, C? They already gave us that, and that's given.
Oh.
The red angles are given.
BC and DC.
So you're telling me that I know something about this angle, this side?
Oh, wait.
Do I know that?
No.
No. What did I just highlight, guys? You're complicating this again. What did I highlight?
C.
Okay. But C is split into what?
Two equal
Two
parts.
equal parts. What are those equal parts?
A and B. Wait. B and D?
No, B and D already was given. Guys, okay.
No.
Here's my bisector. Bisector cut angle C in half to make two angles. What are those two angles?
No, those are given.
What two angles did I just create by cutting C in half?
Angle C, because it's in half.
But it's in half. So if I say angle C, I don't know which half you're talking about. My bisector did not even touch B or D. So that's not what I'm talking about.
A.
Okay, I have this big angle. I'm talking like a child because this is much easier than everyone thinks it is. If I had that big angle and I cut it in half, what are the two halves of that big angle?
BC and CD.
Those are not angles. I'm
No,
asking,
those are sides.
what are the two angles that I have created?
C and C.
But give them names because C can refer to two different things.
C and C prime. I don't know.
I need 3 letters to give me a name. What 3 letters make up those 2 angles?
ASA. AAA. Wait, no. Wait, I'm done. Oh my.
He's asking what angle letters make those.
Oh my gosh. How do I not know this? I'm dumb.
Anybody? Tyrone's not the only person in this class.
I'm trying.
Oh my god, you guys. I'm sad right now.
What was it?
This is sad. Miss Lopez is weeping.
What was it?
Angle BCA is congruent to angle DCA. Look.
What? What? I just. Oh my.
You what?
But I swear
Did
I
you
said that.
say no?
Oh,
No,
where
no,
I said
nobody said
ABC
that.
and AD. Oh my.
Nobody said that. Nobody said that. So now we know. And now you're not going to make that mistake again and make Miss Lopez really sad. We have 2 angles. BCA. BCA is one of them. And the other one is DCA. Because if you just say angle C, I don't know which of those you're talking about. Because both of them are angle C. So you got to be very specific. That's why we use those 3 letters to help us out. So I split that into 2 different angles. And I gave them 2 different names so that I can specify which one is which. All right, what's the last piece of given information that I haven't written down yet?
B and D.
B and D. How come I can give these just 1 letter?
Because they were already given. Wait.
Like, how come I can say angle B, but I can't say angle C by itself?
Because C was cut in 2.
Because C was cut
And
in
B
2.
and D weren't.
Right, because B and D are on their own, that's fine. But if I'm saying angle C, I don't know if you're talking about the top half or the bottom half. Okay? All right, and now what theorem can I use? Oh, and I'm sorry, the first one I just realized was not given. What's the first reason?
Reflexive.
Yeah, that's reflexive. Okay. Now what can I use? Which theorem can I use to prove?
AAS.
Yeah, this is AAS. Okay, I'm gonna move on because that took way longer than it needed to. So here are all the theorems that we've learned so far. We've done SSS, AAS, ASA, SAS. What's missing?
Wait. SSA.
SSA. Anything else?
CPCTC? No.
CPCTC we already know about, but I'm asking which ones have we not learned?
AAA.
Good, AAA. So what I'm going to do next is I'm actually going to show you guys why SSA and AAA don't work. Because those are fake news. Okay, those are not theorems for a reason. So what I'm going to do now is I'm going to switch over to my camera and I'm going to show you guys why those don't work. So give me just a second to set that up.
That took way longer than I expected.
Same here. Okay. Oh, hold up, it got disconnected. Come on.
Miss Lopez, it's upside down.
I know, I'm working on it.
Oh, I'm sorry, my bad. Oops.
Okay, here we go. Y'all can see it?
Yep.
Okay. So first of all, SSA spells a bad word if you go backwards. So that's
Uh-oh.
one reason. That's already one strike for SSA. But let's look mathematically at why SSA does not work.
Bad word.
So what I'm
Theorem
going
said
to
bad
do, so what I'm going to do is I'm just going to draw an angle, any old angle. Doesn't really matter right now what it looks like.
What happened?
All right, so I'm going to start off. I just have this angle right here. There we go. I'm going to call this one A, and I'm going to call this one B. And what I'm going to do is I'm going to use my compass, and I'm going to draw. I'm going to connect B to any other point. Let's connect it right over here. So this is, I'm going to call this one C. I'm going to connect those. And what I'm going to do is I'm going to just draw a little circle or a little arc from C to another point, which I'm going to call D.
That's how you writing so good.
Don't worry. All right, so now what I'm going to do is I'm going to connect B to C. Okay. And I'm going to measure everything really quick. So what I did was I made this line segment right here, so I'm going to measure that one in inches. And that's about 2, let me see. That's the 2.25. Someone's calling me. Okay. Okay, so that's about 2, and this is a half, this is a quarter, so I'm going to call that 2.25. 2.25 inches. I'm going to measure BC. BC is pretty much exactly 2 inches. Okay, so right now I have 2 sides right here. And what I'm going to do is I'm also going to measure this angle A using my protractor. And when I line it up, I notice that angle A is, let's see, this is 40, this is 45. That's about 47 degrees, I mean. Okay, so this is all the information that I have right now. I have a side, and an angle. So I have SSA. Okay, but I also have this point right here, this point D. I'm going to connect B and D. Now, since I used my compass, remember, I didn't change the measurement. I have this from B to C, and when I went around, I didn't change the measurement at all. So from B to D, what do I know? How much is that going to measure as well? If this was 2 inches and I didn't change that measurement, what does this have to be?
2.
Also 2. And I can check. Let me check.
Because of the pipe.
I line it up, and yep, that's definitely 2 inches. So what I'm going to do is now I've created 2 triangles. I've done this one right here. I'm just going to kind of copy it down. The one with like a really, really skinny angle. This one is A, B, D, and this is 2.25, this is 2, and this is 47. And then I have this sort of big angle, big triangle. A, B, C. And here I have 47, 2.25, and 2. So notice AAS, or sorry, SSA, SSA.
Miss, you're like Jalen now. You say ASS.
I almost did. I didn't. I almost did.
She would have got canceled.
So what's up with these two? Are these congruent?
No, they're
No,
ugly.
they're definitely not congruent. Even though we have two sides that line up and then one angle, this is why SSA is fake news. It does not work. Do I have any questions on why this does not work?
Miss Pearla's a tomato. She needs help. She's dying of laughter. What do I
Oh,
do?
Perla.
She's a tomato.
Just let her be.
She's
She needs to
laughing at
giggle it out.
nothing.
She needs to giggle it out of her system.
It's because she's tired.
That's fair. I get it. All right. Questions on why SSA does not work?
No.
Okay. So that's SSA. Now let's see why AAA doesn't work. Okay. So now what I'm going to do is I'm going to start with the same thing I did. So I'm going to start just by drawing any old angle. Doesn't really matter. Okay. So I have this angle. Let's call this A. And let's put a point right here and call this one point B. Okay. What I'm going to do, yes, question?
Wouldn't it be impossible for AAA because for a triangle, you at least need one side or...
You'll see why in just a moment. You're close, but not quite.
Okay.
Okay, so what I'm going to do now is I'm going to draw a parallel line, a line that's parallel to A, okay? It's going to be parallel to A, but it's going to cross B. So it's going to be somewhere over here. But if you guys remember, we actually learned how to do this. So I'm just going to review how to create a parallel line. So the first thing I'm going to do is I'm going to set my compass at A and just draw an arc. And I'm not touching anything. I'm going to copy that arc down over here. Okay. Then I go to the point I've created right here. And I'm going to set my compass equal to that distance. So I just changed it so it's at that distance. And I'm going to copy that over here. And I'm going to draw a parallel line that crosses these two little arcs. Okay, so now I have two parallel lines here and here. And my last thing that I'm going to do is I'm going to draw one more. I'm going to draw one more. Hold on, let me figure out where I want to do this. Give me 1 second, guys. Yes, okay. I'm going to draw one more side that's going to cross anywhere, but it has to cross both lines. So let's do it right here. I'm going to call this one, let's see, let's call this one C and this one D. Okay, so I've kind of done a couple of things here, but basically I have two triangles. So notice I have this big triangle ADC. So this big triangle and then this little triangle. Okay, and I can call this one, what haven't I used, F? Okay, so I have ADC and I have BDF. Are these two triangles congruent? Big triangle and little triangle?
No, that's a
Good.
dilation.
Yeah, definitely not congruent. But now let's think about these angles, okay? So I'm gonna color code. Let me get some colorful markers. Okay, so what do I know about angle A and angle B? If these two lines are parallel,
They're congruent.
angle A is congruent to angle B. What type of angles are they?
Corresponding.
Corresponding angles, good. Let me get another colorful, hold on 1 second.
Coloring with Miss Lopez.
Okay, What about angle C and angle F?
No.
Are they congruent?
No.
But remember, these two lines are parallel.
Oh, yes.
What are these to each other?
Corresponding.
Also corresponding. Now, what about angle D to itself? Because angle D is in both triangles. Both of them have angle D. Is angle D congruent to itself? It's not a trick question. Is angle D congruent to itself?
Yes.
And what's that called?
Flexive.
Reflexive. So angle D is congruent to angle D. So let me redraw these two triangles. I have little triangle. Sorry, this is B, D, F. And then I have big old triangle. A, D, C. And I know that A is congruent to B, that F is congruent to C, and that D is congruent to itself. So here I have A, but these two triangles are not congruent to each other. So for that reason, AAA does not work.
This is basically like if you took a shape and you did a dilation by how many times you wanted, like you're making it bigger, but it's still gonna have the same angles. But
Right,
that doesn't mean it's still congruent because it
right.
doesn't have the same side lengths.
Exactly. The angles the angles stay the same,
Dilation.
but the side lengths definitely change. So even though the angles are the same, those two triangles are not congruent. So AAA and
SSA are false.
SSA are false, fake news.
Bad.
Let me change to where we were. Okay. Questions on why those things don't work? Questions on anything at all so far?
Can I have Khan Academy?
There will be.
Yay.
Okay. So here's the last thing, which is what Daniel kind of hinted at before when we did that previous problem, which is our last type of congruence theorem, which is called hypotenuse leg, or HL. So the HL theorem. Can I have a volunteer read the HL
If the
theorem?
hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent.
Good. So notice this is a special case because here I have an angle and what? And two sides. So in theory, technically, this is S, S, A. But hold up, I just said that SSA doesn't work, right? So
Yeah.
the only time that this works is if you have a right triangle. Only if you have a right triangle. And the reason is the Pythagorean theorem, exactly. So in this, take 1 minute to copy down the HL theorem.
I never imagined doing this.
Who still needs a second?
Me. One. Okay, I don't need the second no more.
Anybody else still need a second? Okay. All right, so let's again show why HL is the only exception to the SSA rule.
Ooh, miss.
Oh, Miss, we
Ooh,
see you.
and And this meeting is being recorded. Ooh.
Ooh, I promised, I told myself, I was like, oh my God, Miss Lopez, don't say it, don't say it. And then you know when you tell yourself what
He
not
did
to
the
say?
Jalen.
I did the Jalen. I'm so sorry. Okay, so yes. So the reason HL is the only exception is because of the Pythagorean theorem. Can somebody remind me what is the Pythagorean theorem? In general?
A squared plus B squared equals something squared. Wait,
A
C
squared.
squared.
C squared, yeah. Where C has to be the, what's the name of that specific side? The longest side?
Hypotenuse.
Good. This is the hypotenuse. And A and B are my legs. They're called legs. So
That's sad. He doesn't have arms. So sad.
just legs. All right, so in triangle ABC, I know that A squared plus B squared equals C squared. And what about triangle DEF? Can anyone set that one up for me?
F. Wait. B squared plus F squared equals E squared.
Not quite. Which one's the longest side? Look carefully.
Oh, D squared plus E squared equals F squared.
There you go.
Big brain.
Okay, good. So we have that. So far, we know that. Now, looking at the congruence statements in the diagram, which of those sides are equal to each other?
Of like each shape.
Yeah, in the diagram.
So A is equal to D like
A.
that.
A.
Yeah, A
And
is equal
B,
to D.
B is equal to E, and C is equal to F.
Okay, but the only ones we actually know are the ones that
Oh,
they
yeah.
drew. So we don't know about
Okay.
B and D yet. In our heads, we know they are, but not yet on paper. Okay, so I know A is equal to D. So I know, let's see, I know that A is equal to D, right? So this A squared has to be equal to D squared. And then I know that B is equal to E. No, I don't know that yet. My bad. I know that C is equal to F, so I know C squared is equal to F squared. Okay, which leaves one option for us, B and E, right? Now, the way that I can set this up mathematically to show that B and E are equal to each other is, on the green equation, I can subtract A squared from both sides. So this is B squared equals C squared minus A squared. And on the right hand, on the blue equation, I can subtract D squared from both sides. So I can say, okay, if I subtract D squared from both sides, I know that E squared equals F squared minus D squared. But hey, I know that F is congruent to A, or C, and that D is congruent to A, so I can replace those values. This is the same as C squared minus A squared. And where do we see C squared minus A squared written?
And the other one?
Yeah, in my green equation, right here. So I can replace C squared minus A squared. Substitution, exactly. So I can say that E squared is equal to B squared.
D squared.
Which means that I can finally say that B,
Triangle. Yeah.
that B is congruent to E, which means that those two triangles are congruent to each other. So obviously, yes, I'm showing this using a lot of math and why it's true, but all you have to remember is that this only works on which type of triangle? Which type of triangle is this?
Right triangle.
Right triangle, good. This will only work with right triangles. Okay, so again, SSA is fake news, but HL does work. Even though HL is a kind of the same thing as SSA, it's only in this case that it's going to work. I think this is the last problem. We only have 4 minutes, so let's just quickly go through this as quickly as we can. What's the first one? Good.
Definition of a midpoint.
Okay, hold up. Okay. K is the midpoint. That one's actually also given.
Oh, given.
Now you can tell me what you said.
Definition of a midpoint.
Yeah, so now we know that JK is congruent to KL or LK. So I know these two are congruent. And I know that MK is congruent to NK. And both of those is because of the definition of a midpoint.
HL.
Good. And since I have a hypotenuse and one leg, I have HL. I know that these are congruent.
Hey, I did all of them.
You did. Good job. All right, we kind of sped through that a little bit, but hopefully, we can put all of this together. Your homework that's due on Wednesday, I'm going to put it up in just a moment. And that homework assignment now puts everything together. So you're going to be doing ASA, SSA. It's 4 proofs. So the assignment is 4 proofs. And those proofs will use all of the 5 or 6 theorems, if you count CPCTC, that we've learned so far.
You can do anything with Tyrone on your team.
Any final questions before I let you guys go a couple minutes early?
I have a big brain.
Okay, I'm going to go ahead and put that assignment up right now.
And will Jalen get in trouble?
What?
Will you get in trouble? If Jalen gets in trouble, you get in trouble too, miss.
I'm not in trouble. Nobody's in trouble. The thing is, nobody said that word out loud. All we did was spell it. So we're all good.
That's true, though. Plus, it's math, so it's different.
Yeah, exactly. We weren't
But you
saying the
didn't
word.
mean to say it on purpose, so
Exactly.
nobody gets in trouble.
All we were doing was learning.
All we were doing was learning. Okay, so I'm about to assign it. So it's one set of problems, 4 problems. And then the other thing that I'm assigning is just a little review document that you can use to help you out. So it's not an assignment, it's just a little bit of a review. Okay, so it is all up for you. As soon as you get home, you can get to work and you guys are all done. Have a good day. You guys did very well today. Shout out to
Yay.
anyone who participated. Goodbye.
Bye, man.
Bye, guys.